Hey guys, welcome again to the Maths Club. If you are just joining us, this is a good place to hit the subscribe button and click on the notification bell so that anytime we drop a new content, you are the first to know. In this video, we're looking at graphs of linear and quadratic functions, but we are going to be focusing on linear graphs. So linear graph really represents a linear equation in two variables. Linear equation are things like where you have y is equal to 5x plus 3. You can see there are two variables. There's a y variable, there's an x variable, and it's a linear equation because the highest power of x is 1. So if you have y is equal to 5x plus 2, you can see that there the highest power of x there is 1. X is power 1 is x. But if you have something like let's say x squared minus 3x plus 5, right, you can see that the highest power of x there is 2. That is no longer a linear equation. The graph of a linear equation is a straight line graph. We know is a straight line graph. So you can see that forms of linear equations, you could have it in the standard form where you say maybe 5x plus 3y is equal to 2, right? The c there is standing for a constant, right? The x and the y are in fact the a, b and c, they are all constants, meaning that they can be values like 2, 3, 4, 5, things like that, right? So it could be 3x plus 5y is equal to 2. The x and the y are the variables. So it could be in the slope intercept form, in the form of y is equal to mx plus c. We're going to see what this m represents and what this c represents in this particular case shortly. So how do we plot linear graphs? First step is that you identify the equation that you want to plot. Then you create a table of values. Then you plot the points from the tables of values on the graph. And then you draw a line to connect all of those points. Now let's talk about interpreting linear graphs. I talked about the equation y is equal to mx plus c. The m represents the slope of the graph, right? The slope is how steep the line is. So you know that if you're driving, sometimes if you're driving downhill, so that sometimes the car will just be going, even if you drive very well or if you've been in your parents' car, whenever you're going on a place that is sloping, that is going downhill, you see that you don't even need to even press the accelerator. The car is going down depending on how steep. There's some hills that are very, very steep, or there's some hills that are very, very steep that you have to hold the chair in front of you, right? Because of the way everybody will be feeling like you're going down, right? So that m there is what is speaking to that steepness of the line or of the road, right? And then the c is the y-intercept. That means if you have the x and the y-axis, right? So you have the x-axis going from left to right, so you have the y-axis going from down to up, right? Where the line will cross that y-axis is the c value, right? So you can say that the c is the y-intercept where the line crosses the y-axis. Let's say an example. If you have y is equal to 2x plus 1, you can say that if I compare it vis-a-vis this particular equation, which is y is equal to mx plus c, m there is equal to 2. That means that the equation of this line has a slope of 2, and if we say plus c, this is plus 1, really it has a y-intercept of 1. So these are how you interpret questions like this. So there's a formula for calculating the slope. The slope is how the value changes in the y-axis over how the value changes in the x-axis. You can see the equation of the line is y is equal to mx plus b. Plus b here is where it intercepts the y-axis. So you can see where it intercepts the y-axis here, right? I know we use c in a particular, but it's just a constant. It could be any value. So the b here is where it crosses the y-axis. So you can see it's represented here plus b, and you can see your m is speaking to the slope, right? So how we actually really do it is that, and we're going to do that when we're going to be plotting, is that you pick a portion of this line. The portion of the line should be something very big. I think in the WAEC, the market, I think should maybe 2/3 of the line or something like that, or 1/3 of the line, something like that. So just don't do something very small here and say that is no, you have to use something big. So you draw a line that is parallel to your x-axis. So it's parallel to this x-axis, and then you draw a line that is also parallel to the y-axis. So you can see a y-axis. I mean, pick two good points. So this point here is your first point, which is x1. This point here is your x2. This point here is your y1, and this point here is your y2. So by the time you say, oh, change in y over change in x, that should give you this slope. And we're going to look at this in real life. I know it's all theories now, but it's fine. So you say where change in y is, or delta y is change in y, and delta x is changing the x values. So let's say an example. The example says that find the slope given 2 points 1,3 and 2,5 of a straight line graph. Let's solve it together. So if you're familiar with things like this, these are points 1, this is 1,3, and these are points 2, 2,5. Of course, this speaks to the x-axis, this speaks to the y-axis. So this is our our x1, this is our y1, this is our x2, this is our y2. So for the formula for slope, which is m, we said this is change in y all over change in x. So that will be this y2 minus y1 all over x2 minus x1. So where's our y2? Our y2 here is 5, our y1 here is 3, our x2 here is 2, our x1 here is 1. So that will be, if I do this, 5 minus 3 is 2, 2 minus 1 is 1. So that means our slope is just 2, right? A positive value. So you can see our value is actually 2, correct? And let me say something. If you look at, if it is a rising slope, for a rising slope, right, the slope is going to be positive, a positive value. But for a slope that is going downwards, there are times that the line is going downwards. By the time you do the slope, you see that the value is going to be a negative value. Look at it. This is an higher value of y. This is a lower value of y. By the time I do y2 minus y1, of course it's going to be a positive value because this value is higher than this one, right? And also to look at this x value on the number on the x-axis is higher than this one. So I have a high value of y minus a low value of y all over a high value of x minus a low value of x. Of course, you can see positive at the top, positive at the bottom. You're going to have a positive value of slope. So the second example says that given the linear equation 2x plus 3y is equal to 6, find the coordinates of the points where the line cuts the x-axis and the y-axis, and then plot the graph of the equation on a graph paper. Then we should find the gradient by taking measurements. I know by the time we make the y-slope of the formula, we can be able to find what the gradient is, but they want us to take measurements from the graph itself. So let's solve this together. So we're given 2x plus 3y is equal to 6. And it says we should find the points where the line cuts the x-axis and the y-axis. So let me do a small graph here. So if I do a small graph here, and then we have a point where it crosses, see, this is the point where it crosses the x-axis, and this is the point where it crosses the y-axis, because this is our y-axis and this is our x-axis. At this point here where it crosses the x-axis, do you notice something? The y value here is 0, right? So we need to find the x value, right, when y is equal to 0 for us to know where it crosses the x-axis. And for where it crosses the y-axis, look at the y-axis here. You've also agreed that this point 2 is also, look at, there's a value of y, right, when the value of x is 0. So this point here is 0. If I wanted to represent this point, this will be 0 comma something, 0 comma y, right? So we need to find the value of y when x is equal to 0. So let me come again. Look at this place here. It's crossing the x-axis, but look at, there's a value. It could be something like this, right? This line I drew here. You can see it's crossing the y-axis somewhere here, and it's crossing the x-axis somewhere. I don't know the place here, but I know that in this place here, y is 0 because it's at the base point, and I know that in this place here, x is 0 because at the base point. So I need to just find the value of y, right? To use some value on the number line. So given that, so we're going to find the x-axis interception. That is when y is 0. So when y is 0, let me substitute. That would be 2x plus 3 open bracket 0 is equal to 6, and 2x is equal to 6. So if I divide both sides by 2, x is equal to 3. So this is the intersection point. So this is, if I say, this would be 3, 0. Also too, for the y-axis interception, so that will be where x is equal to 0, right, based on what we did here. So when x is equal to 0, that will be 2 open bracket 0 plus 3y is equal to 6. So this 3y is equal to 6, and if I divide both sides by 3, our y is equal to 2. So we know that in this place, this is 0, 2. So this is the y-axis interception and this is the x-axis interception. Now, for us to actually now plot the graph, we will need to do our table of values. So for a straight line graph, really, you only need like 2 points, right? But I'll just put these extra points just for putting sake. So this, you put your x value here, your y value here. So we already have 2 points here when x is 3, right? And when x is 0. So I'll just say 0, let me just say minus 3, 0, and 3, right? Just to fulfill our righteousness sake. So we have minus 3, 0, and 3, because we had 2 points here. We had when x is 0, when x is 3. So when x is 0, the value is 2. When x is 3, the value is 0. So we just have to find when x is minus 3. So for the last point, we could say when x is equal to minus 3. I do, like I said, we only need 2 points because it's a straight line graph. But just for fulfilling our righteousness, so let me substitute. That would be 2 open brackets minus 3 plus 3y is equal to 6. So this is minus 6 plus 3y is equal to 6. And then 3y will be equal to 6 plus 6. So 3y will be equal to 12. Y will be equal to 4 if I divide both sides by 3. So our value for y here is 4. So with these 3 points, or with these 2 points really, and then these extra points, we can be able to plot our graph. So we have this. These are equation and these are table. So the least value of x is minus 3. X value is 3. The least value of y is 0. The x value is 4. So I mean, each of these boxes can just be 1 units. So I could say for the x-axis, 2 centimeter will represent 1 unit. And then for the y-axis, I could also say 2 centimeter will represent 1 unit. Right? So I'll just point it out. And I'll just say, let's say these are our 0th position. These are minus 1. These are minus 2. These are minus 3. These are minus 4. These are 1, 2, 3, 4, 5, 6. These are minus 1. These are minus 2. These are minus 3. These are 1, 2, 3, 4, 5 positions. So I'll just draw a line, y-axis, and the line for the x-axis, right? So you have to label afterwards. So these are y-axis. Oh, sorry, these are x-axis, and these are y-axis. Ensure you label. I think there are marks for everything. So when x is minus 3, y is 4. When x is minus 3, y is 4. So this place here. When x is 0, y is 2. When x is 0, y is 2. So this point here. And when x is 3, y is 0. When x is 3, y is 0. So this is just the points here. So I will draw a line to connect all 3 points. Great. So after I draw the line, I have to now label it and say this line is the line of 2x plus 3y is equal to 4. You notice our slope is going downwards from left to right. It's going downwards. So this point here will be our position 1. This will be our position 2. So let's look for a point in this table that is very good for slope. So maybe I should just draw something like this. Let me use something very big. Your slope should always be very big. Don't do a small slope. Right, so let me also draw it here. Great. So these are position 1 because it's sloping downwards, and these are position 2. At position 1, what is the value? The x value is minus 3, right? The y value is 4. At position 2, the x value is 4.1, 4.2, 4.3, 4.4, 4.5. So this is 4.5. And then the y value is minus 1, right, from here. So we just point at this place and here. So we can now begin to, okay, so how do I know that's 4.5? So let me just draw this up, just to be sure I'm not making any mistake. So this 4.1, 4.2, 4.3, oh, it's actually 4.4. So this 4.4, not 4.5. That's why it's always good to always trace it up. Now, for this, our slope m will be equal to y2 minus y1 all over x2 minus x1. Our y2 value, this is our position 2, is minus 1. Our y1 value is 4. So this is minus 4 all over. Our x2 value here is 4.4. Our x1 value here is minus 3. So minus 1 minus 4 is minus 5. Then 4.4 minus times minus is plus, so that will be plus 3. So this is minus 5 all over 4.4 plus 3. That will be 7.4. So minus 5 divided by 7.4. Minus 5 divided by 7.4. That will give us minus 0. Let's just say 67 or 68. Let's say 68 to 2 decimal places. So these are value. minus 0.68 to 2 decimal places. So this is particular solution to this question. So just like we did, our answers correlate. This is 0, 2 and 3, 0, and we can see our graph exactly like what we had, and then our slope is minus 2 over 3. Great. Next example says that we should complete the table which shows the value of x and y for linear equation 3x minus 2y is equal to 4, and then we should plot the graph using values from the table, and then from your graph we should find the value of y when x is 5 and the value of x when y is equal to minus 3. So in this case they give us like 5 different points that we should find the x values, although if it's a straight line we need like 2 points, but these are the points to help us to guide. You have to show it on your graph when you are actually plotting all these points. So let's complete this table together. So our equation is 3x minus 2y is equal to 4. Great. So we can now just say when x is equal to 0, this will be 3 open bracket 0 minus 2y is equal to 4. So this will be 0 minus 2y is equal to 4, and this minus 2y is equal to 4. If I divide both sides by minus 2, our y is equal to minus 2. So this is minus 2. Then when x is equal to 1, so this is 3 open bracket 1 minus 2y is equal to 4. So this 3 minus 2y is equal to 4. Minus 2y is equal to 4 minus 3. When I carry 1 to the other side, that would be minus 2y is equal to 1. And if I divide both sides by minus 2, what is our y? Our y value is minus 1 over 2, or minus 0.5. So let me just say minus 0.5. So when x is equal to 2, we can substitute and say there will be 3 open brackets 2 minus 2y is equal to 4, which is 6 minus 2y is equal to 4, which is minus 2y is equal to 4 minus 6, because this come over is become minus 2y is equal to minus 2, and if I divide both sides by minus 2, my y is equal to 1. So I'll put this guy as 1. So when our x value is equal to 3, that will be 3 open brackets 3 minus 2y is equal to 4, and this 9 minus 2y is equal to 4, minus 2y is equal to 4 minus 9, minus 2y is equal to minus 5, and if I divide both by minus 2, our y is equal to 2.5. So let's substitute, that will be 2.5. Then finally, when x is equal to 4, that will be 3 open brackets 4 minus 2y is equal to 4, and this 12 minus 2y is equal to 4, minus 2y is equal to 4 minus 12, minus 2y is equal to minus 8, and if I divide both by minus 2, our y will be equal to 4. So this guy is 4. So we are armed with all of these points. We're going to plot it on the graph table, and then we're going to draw a line and find all of the questions that it told us to do. So for this question, we're given the equation to be 3x minus 2y is equal to 4, and we have gotten our x values and y values. So let's plot it. So the lowest value of x is 0, the highest value of x is 4, lowest value of y is minus 2, the highest value is 4. So on the scale axis, I can just use 2, because each of these places here is 2 centimeter, and this 2 centimeter. So I could say on the x-axis, 2 centimeter would represent 1 unit, and then on the y-axis too, I could say 2 centimeter would represent 1 unit too. Right, so I have this. Then the next thing is just to, let me just put some hypothetical situation. So I could just use this, please. Let me start from here. So this is my 0 point, this is my minus 1, this is my minus 2, this is my minus 3, this is my 1, this is my 2, this is my 3, this is my 4, this is my 5. So on the y-axis, so this is my 1, this is my 2, this is my 3, this is my 4, this is my 5, this is my 6, this is my 7, this is my minus 1, this is my minus 2, this is my minus 3. So let me just draw a line now. Then I'll label the axes. This is my x-axis, and this is my y-axis. So now let's look at the points. When x is 0, y is minus 2. So this is x is 0, y will be minus 2. This is minus 2 here, so I'll just point it here. I'll do it an x. When x is 1, y is minus 0.5. When x is 1, this is minus 1, so this is minus 0.1 minus 0.2 minus 0.3 minus 0.4 minus 0.5. So this is it here. So I'll put an x. When x is 2, y is 1. When x is 2, y is 1. So this is where they meet. When x is 3, y is 2.5. X is 3, y is 2.5. So this 2, 2.1, 2.2, 2.3, 2.4, 2.5. So I'll just mark this point here. When x is 4, y is 4. So I'll just mark this point here. Then I'll join all of them with a straight line. After I join all of them with a straight line, I have to label the line and say this line is for the equation 3x minus 2y is equal to 4, right? And this is an upward slope. You can see it's going up like this. It's going in this direction. So now we're told to find the value of y when x is 5. So when x is 5, I'll just take where x is 5 and trace it up to where it touches the line. So this is x is 5, so I'll just trace it up to where it touches the line. Let me draw that, and you can connect it with like dashes. So I will now extend that place that it touches the line here. I will now also draw a horizontal line to touch the y-axis. So this point here, this 5.1, 5.2, 5.3, 5.4, 5.5. So this 5.5. You can just extend it a bit so that they will know that it's 5.5. So when x is equal to 5, y is equal to 5.5. And then when y is equal to minus 3, so this is where y is equal to minus 3. What is our value of x? So I still need to extend this line small. Right, so let me just extend it a bit. So when y is minus 3, right, so it will have to now come here and join the line. Right, that's why I have to extend it. So this is it joining the line here, right? So I'll just draw up this place here. Then I would draw it to join the x-axis. So if you look at it, this is like minus 1, minus 2, minus 3. So if you look at this like minus 0.1, minus 0.2, minus 0.3, minus 0.4, minus 0.5, minus 0.6, minus 0.7. So it's approximately minus 0.7. So when y is minus 3, the x is equal to minus 0.7. Although this is where the question starts, but let's assume that I wanted to take the slope of this particular question, so we can do that too. I will just look for some very convenient points. So I could just do something like this. Let me trace it down, look for something very big. Your slope should be like 2/3 of your line or something. Then I will just draw this place here. Right, so since this is going up, this will be our point 1, and this will be our point 2. So these are point 1, these are point 2. So if I trace it to this place, let's find out what the y1 is and what the y2 will be. So I also trace this one to the y-axis and trace this guy here to the x-axis, and this one here in this. So this is my, because it's going up, this is my point 1, this is my point 2, right? At this point here, the x value is, so this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So this is 0.7, comma, the y value here is minus 1. And this one here, this is my point 2, the x value here is 4. And then the y value there is also 4. So if I wanted to find the slope, although it's not, we're not able to just say m is equal to y2 minus y1 all over x2 minus x1. So our y2 here is 4, right? So this 4 minus our y1 here is minus 1. That will be minus 1 all over our x2. Where's our x2? Our x2 here is 4 minus our x1 here is 0.7. So this will be 4 plus 1 divided by 3.3. And 4.1 is 5 all over 3.3. So if I press my calculator, that's 5 divided by 3.3. That will give me 1.515 to 3 significant figures. So that's basically how we actually solve a question like this. So we have our table complete, correct, our graph correct, and then our y value at the position of x to be 5.5, and then our x value at the position of y that was stated as minus 2 over 3. Great. Example 4 says that A straight line has the equation 10y is equal to 3x plus 15. Which of the following is true? Right, so you can see the options. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we're told that straight line has the equation 10y is equal to 3x plus 15. If I divide both sides by 10, 10, 10, right? This will be y is equal to 0.3x plus 1.5, right? And if I deduce this, or if I juxtapose this with our equation of y is equal to mx plus c, which is the equation of a line in the slope-intercept form, the m value is 0.3 and then the c value is 1.5. The m value stands for the slope, the c value stands for the y-intercept. So let's see which of the options correlate to this. So that would be option A. If you got this, well done to you. So equation of a straight line, we can derive the equation of a straight line given two scenarios, right? When we are given the slope and one of the points. So we are given the slope and one of the points. So we can use this equation, y minus y1 is equal to m open brackets x minus x1. The x1 will be the x of the points given, and the y1 will be the y of the points given. Or if we are given 2 points, x1 y1, x2 y2, we can use this equation to solve this. So you can see the y here is the variable, this is the variable, all these y1, y2, y1 are the points that you'll be getting from all of your given points. So let's see some examples to just bring this home. Example 5 says that a straight line makes intercepts of -3 and 2 on the x and y axis respectively. Find the equation of the line. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So from the previous video, I said that the x-intercept is where the y value is 0, right? When y is 0, the value of x would be -3. So we have our first point to be -3, 0, and then we said y-axis intercepts, right, will be when the x value is 0. So that would be 0, 2, right? From this we're given. So these are x1, these are our y1, these are our x2, these are our y2. So we said the equation that we were told was that, so let's just revert back to the equation. We use y minus y1 all over y2 minus y1 is equal to x minus x1 all over x2 minus x1. So solving that, that would be y minus y1 all over y2 minus y1 is equal to x minus x1 all over x2 minus x1. So let's substitute. That will be y minus y1 is 0, our y2 is 2, 2 minus 0, our x is the variable minus our x1 is -3, and then our x2 value is 0 minus our x1 value is -3. You have to be very careful when picking these values. That's one of the first places people make mistakes. Y minus 0 is y, 2 minus 0 is 2, x minus -3, that would be x plus 3, all over 0 minus -3, that would be 0 plus 3. So this y over 2 is equal to x plus 3 all over 3, right? So if I cross multiply, that would be 3y is equal to 2 open brackets x plus 3. So this 3y is equal to 2x plus 6, right? So this, we can actually leave the equation like this, right? 3y is equal to 2x plus 6. Or we could leave it in the slope-intercept form and say I could divide all through by 3. That would be y is equal to 2 over 3x plus 6 over 3, right? That would be 2 over 3x plus 2. So anyway, out of these two, right, is actually correct. Let's see if we're correct. So you can see, so 3y is equal to 2x plus 6. Example 6 says that we should find the equation of a straight line that passes through the points 2, -5 with the gradient of -3. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. So to solve this question, we're given one point which is 2, -5, and we're given the slope m which is -3. So we can go back to and look at the equation that actually fits this scenario. So you can see that when we're given 1 point, we said we should use y minus y1 is equal to m open brackets x minus x1. So y minus y1 is equal to m open brackets x minus x1. This equation is actually taken from the place where we said m is equal to change in y all over change in x. We say y2 minus y1 all over x2 minus x1. Well, in this case, our y2 here is the y, and then our x2 here is the x. So if I cross multiply this, you will see that this will be m open brackets x2 minus x1 is equal to y2 minus y1. So you can see the y2 here is y, the x2 here is x. These are actually got the formula. That aside, let's substitute. So that will be y minus our y1 is minus 5 is equal to m open bracket x. Our x1 here is 2. So that will be y plus 5 is equal to, oh, our m was actually, we're given the value of m as minus 3. I didn't substitute that. So that will be minus 3x. Minus 3 times minus 2 will give me plus 6. So let's rearrange. That will be y is equal to minus 3x plus 6 minus 5. And our y value will just be minus 3x plus 1. So you can see even tallies that our gradient, which is our m value, is still minus 3 here. So this is the equation of this particular straight line. Let's see if we're correct. Great. Y is equal to minus 3x plus 1. So we've actually come to the end of this particular video, and I will enjoy you to like the video if you found it useful. Comment if you have any question. Share the video with somebody that you know can help. Right? You found this video and you find this channel. It is imperative that we share the word to other people too. I'll see you guys in the next video. Bye for now.